Yeah. Welcome to my presentation. Thanks for Luis to give a chance today. Today we will talk about unlocking potential of the GraphQL in Android development. And first of all, I would like to say something about me. And yeah, it's okay. Yeah, I am Selim. I work as an Android engineer in Holiday Pirates Group. This is a bit different because the not traditional event today in SumUp. Thanks also the SumUp company. Yeah, what is our content? We will delve into the significant of efficient network communication, explore the REST APIs, introduce GraphQL, discuss challenges faced with the REST, summarize the advantages of the choosing GraphQL. Maybe I can choose this one because it is not fit for my screen. Let's try again. Yeah. Yes. First question, how many people only use the REST APIs in the company or project? Less than expected. Okay. Yeah, maybe. Yeah, otherwise, I think how many of us using GraphQL or heard before? Good. Better than expected. Yeah. And let's begin the importance of the network communication in mobile or our clients. It is working? No. Yeah. Yeah, sometimes delay. Yeah, efficient network communication. The battery life is important for us because we normally would like to transform the less data, but in real life is not expected than our applications, energy efficiency, or new devices. But end of the day, the battery is very important than the user expectation part. And second one is the scalability. When network communication is optimized, the application can better handle the large number of the users and data requests, improving its scalability and performance under increased load. Bandwidth optimization, streamlining communication, helping utilizing network bandwidth more efficiently, ensure that data transfers are efficient and minimizing the consumption of unnecessary resources for us. Yeah. Support for the low connectivity, optimized connection is critical for users in the areas with limited connectivity, enabling application to function reliable and provide essential services even under challenging network conditions. Especially the Berlin metro has a network connection, but other cities not the same in the Germany. Improved user experience. In recent years, many statistics show that when screens in the apps load slowly, users tend to uninstall those apps. I think it's okay. Let's start exploring the REST. Sometimes it's not working. REST is a short for the maybe 2 times should I do this? Short for the representational state transfer, represent an architectural style used in design of the network applications, coined by the Rolf Fielding in his doctoral dissertations in 2000. REST provides a structured approach for building scalable and maintainable services. And let's check the REST history. Before the REST, someone used the SOAP. I forgot, but the GraphQL is nearly new than the REST. We will touch it. Uniform interface, RESTful services should maintain uniform and consistent interface, ensuring that the Resources are consistently accessible via standard URLs and standard HTTP methods. Yeah, these URL correspond to some methods. I think everyone knows the classical REST API. When client sent a request with your specified URL, server handle it and return classical JSON response for us. And we have some methods: get, post, put, and delete. Stateless communication. Each request carries all needed information in the REST. REST operates in a stateless manner where every client request must carry all essential details for the servers to proceed it, and servers do not retain any client-related information between the requests. Let's check. Yeah, scalability and performance. REST is a state-free and caching mechanism contribute to improved scalability and performance of APIs, as a resource can be distributed and cached efficiently. And shortly, the REST offers some advantages for us, emphasizing simplicity, adhering well-defined standard. REST ensures seamless compatibility, effortless scalability, efficient caching, and stateless design for optimal performance. Sounds good for this? Yeah, let's check the GraphQL. In GraphQL, we have some field types categorize data into scalar, representing atomic value like a string or numbers, and object representing complex structure with nested fields for us. Enum types define a specific set of allowable values for a field, contributing to well-defined and flexible data schema. And the second and important one is the schema. GraphQL starts by defining schema that describes type of the data can be accessed and their relationships, serving as a contract between the client and server, outlining available queries and mutations. Especially iOS and Android part, we are using the Apollo GraphQL. You can check the Apollo sandbox, and we will touch it as a live sandbox usage. Yeah, here is a sample schema. This is a screenshot, but I will show some dynamic example for us. Yeah, next up, queries. Another key pillar of the GraphQL. Queries in the GraphQL are optimized requests for the data from servers molded by clients needed, specifying desired fields along with any filtering, sorting arguments for us. And we can see some small example about queries. Yeah, here is a complex example for us. Our client sent just one request with related whatever it needs. First, we need a post samples, but we also require some desired properties, relationships, as a which company, which author related with this post. And this is just one request and one response for us in GraphQL. Mutations, another key concept. It is like a delete or update in the REST. Mutations very similar to queries, but they use to modify data on server directly. They can perform actions like creating, updating, or deleting data. If we want, we can set some user roles to our schema and manage who can send delete requests or update requests related data. Yeah, challenging with REST. REST poses distinct challenges, and we tackle these challenges by adapting GraphQL. Overfetching and underfetching. When utilizing the REST APIs, overfetching refers to receiving an access of the data, while underfetching entails not obtaining sufficient data for us, potentially affecting both performance and user experience. Then GraphQL solves this problem by allowing client request only the specific data they need, eliminating both data overfetching and underfetching issues. client can specify the shape and structure of the response using query language. Then result is the efficient data retrieval. Multiple requests. REST APIs can require multiple endpoints to fetch various data types, leading an abundance of the endpoints and increasing complexity for us. But GraphQL use single endpoint for all queries, reducing number of the API endpoints and simplifying the API architecture. This also simplifies network requests and our code base. Yeah, n+1 query problem. This is the common problem in REST. When we need the multiple data, first we request one data and chain another request with this data result. But GraphQL addresses this problem with its resolver functions, like a gateway of the between server and client. These functions are responsible for the fetching data for each field in query, allowing developers to efficiently batch and optimize data retrieval. Yeah, data loading. The classic REST, single REST endpoint, you usually receive full data set associated with that endpoint, and you know that the backend team define the full endpoint results in the REST. But the GraphQL enable client to fetch only specified data and especially partial loading data. Versioning, maintaining backward compatibility in the REST APIs often ensure the versioning, and any modifications to API can potentially cause breaking change for our clients. But GraphQL's robust type system and version schema facilitate smooth API evolution without risk of breaking changes and allowing clients to request data precise structure they need. Yeah, here is a one small GIF for the GraphQL versus REST. And it is big than expected. Yeah, good. And the GraphQL part, this is single request, but we just use the one endpoint. But the REST part, we have a multiple endpoints, multiple definition in the code base. And another example, in the REST part, our request go to the first microservice and get a response, and we need another data and go to another service. But GraphQL, we just say one request, one precise data, and GraphQL middleware visit the related all microservices and return just one response. Yeah, why we need to adapt to GraphQL? GraphQL was developed by the Facebook in 2012 and was open sourced in 2015. It is fully tested and confident, and we can check all documentation. The first documentation is visible, also open source. And yeah, some of the big organizations use the GraphQL. It serves the performance and scalability especially. And front-end control over data. REST is a server control driven data, and the GraphQL part, front-end control over data, empower the client. We don't want to wait another teams to develop something, because we have a already data set, data sources in the backend part. And end of the day, when we would like to request, got a request from the another teams for the new features, we just develop in the front end part. Also, we know that the our web page has a more area than the mobile, and we don't need to more big response and big data. Yeah, let's. It is also real-time capabilities. GraphQL supports real-time updates through subscriptions to server, enable dynamic and interactive user experience. Yeah, federated architecture. GraphQL's federated architecture facilitates scalability and autonomy by allowing services and manage specific part of the schema. When you install the GraphQL SDKs in the server part, it automatically detects your data sources and document it for you. And we will check it. Versioning and evolution. GraphQL provides backward compatible approach to schema changes, enabling smooth versioning and evolution of the APIs without breaking existing clients. Yeah, and this is another small example. Single endpoint and multiple source. Yeah, here GraphQL allows to parallel data loading, improving performance by fetching related data concurrently for us. The left-hand side is our sample query related with the like a subclasses or another data, and GraphQL visit all related sources for us. And strong type schema in GraphQL means clear rules on what data is available, its structure and types. This clarify helps the developer understand the query and API efficiently and reducing errors and improving efficient during development. Yeah. Finally, GraphQL elevating our development experience end of the day, and efficient development workflow, self-documented APIs, collaboration and front-end independence, versionless evolution, and schema is a powerful source of truth. Here's another real-life example. Before the GraphQL, we used REST in my company, and we migrate, and I put some small example. We got result with the ID name and image, first left-hand side, with blue part. And second one, I added 5 simple string types into the response. When we are using REST, we have to fetch it completely. But in GraphQL, we can use our API without taking new items. Maybe these new items for the web page. Then I checked the response, just 2 kilobytes increased for these new items. And then when we can calculate this, imagine that 1 million active users and each users 5 times a day session for your company. And in that case, we can get rid of some network traffics, some servers, like a 2 kilobytes additional data per session. The 300 gigabytes network traffic end of the day. Thanks for listening, and I will show the real life example for the GraphQL